So in this question, we have to find the filter type and transfer function for a given filter. So see carefully across which terminal the output is taken or across which node the output is taken. It is written that the output should be taken between nodes C and D. Means your output should be across this resistance 860 ohm. So this circuit seems like a complex circuit, but you have to see carefully the nodes across which we are giving input and the nodes across which we are finding the output. So, and try to minimize the circuit as much as possible. Here we are having input across this terminal. Now we can see that this 7 nanohenry and 9 nanohenry inductors, they are in series and they are forming a parallel path with 5.6 nanohenry inductance. So in this case, suppose the total inductance value is represented by the term L equivalent. So we can design the same circuit using one simple inductor which is having value of L equivalent. I am not calculating the whole value here. Now you can see that when the current is flowing through this path, there is one shorted line. So current will not go through this 876 ohm and it will also not follow this path. It is directly going through this shorted line. So now we are having one resistance of 860 ohm. This point was already C, this point was already D. And here we are applying the input supply. So we can see that we are finding the output across this terminal C and D, that is your V output. This output can be obtained by finding the drop across this resistance R. So here when we are designing the transfer function for this kind of filter, it will be always the output upon input term. Here output is obtained across resistance R and the input is supplies across the inductor plus across the resistor. So now we have to represent these terms separately. So it will be R upon J into omega into L equivalent plus R value here. It will be here only. So once this part is obtained, now we have to find out whether it is a low pass filter or high pass filter. So see in this equation, or we can see in this transfer function, whenever we are putting omega equals to 0. So for omega equals to 0, your H omega value, this value will be directly written as, when it is 0, it will be simply 1. When we are having omega equals to infinite, your H omega value, it will be seen as 0 here. So we can see clearly that for low frequency, we are getting transfer function as 1. So it is example of your low pass filter. So it is clear that it is representing one low pass filter. So for completing the transfer function, for finding the cutoff frequency, we have to take H omega amplitude value as 1 upon under root 2. So here we can take as 1 upon under root 2, it will be equals to the amplitude of the numerator and denominator, omega square L equivalent square plus R square. Now we can square both the sides and multiplying the term here, it will be directly written as 2 times of R square, it will be equals to omega square L equivalent square plus R square, or we can write that omega equals to R by L. Since omega value is equals to 2 pi f, it is angular frequency, so we can directly write the same term as 2 pi fc, because we are finding the cutoff frequency, it will be equals to R by L, and now the cutoff frequency will be R upon 2 pi L. So here we can say that the presented figure is your RL low pass filter with a cutoff frequency of R upon 2 pi L. So you have to be careful that whenever we are using this value of inductance here, this L value is representing your equivalent value of inductance, or R value is the resistance, that is 860 ohm here.